In this circuit, the dashed box represents our real-world battery with some internal resistance. So imagine this dashed box is actually the battery. And when we look inside the battery, we see a source of EMF and an internal resistance. So it's as if this internal resistance is in series with whatever we're hooking up to our battery. We're going to call that the load resistance. If there's nothing hooked up to our battery, we have this situation. We're going to hook up our voltmeter to the positive terminal and the negative terminal on our battery. So because the voltmeter has infinite resistance, if it's an ideal voltmeter, then no current flows in this circuit. There's an infinite resistance there. That means if we got out our pens, our highlighters, and we call this the negative terminal of our battery, we call that 0 volts. So we're hooked up to 0 volts here. And the top of our battery, we're going to be increasing by whatever the EMF of the battery is. So this is right here, that's plus E, whatever the EMF of the battery is. If the bottom is at 0, then that has to be that many volts higher. If this is a 9-volt battery, this has to be 9 volts if we're calling the negative terminal of the battery 0 volts. Now, what's the voltage drop across a resistor? V equals IR for a resistor, or delta V. The voltage difference across a resistor is the current times the resistance. If there's no current flowing, then delta V across that resistor is 0. So whatever we had on one side of our resistor is the same voltage we'll have on the other side. So you can see that both ends of my voltmeter hooked up like this, when no current is flowing, the voltmeter reads the EMF of the battery. Now let's hook up our load resistor again and take a look. I'm going to erase where it says positive terminal and negative terminal, and I'm going to hook up my voltmeter there. I'll reach in and put the positive lead there and the negative lead there. Now current is flowing. How do I know how much current is flowing? Well, I'm measuring the potential difference here. So let's get out our colored pens one more time. If we call the negative terminal of our battery 0 volts, then this is all 0 volts here. This line is like an equipotential surface. In here, this little section in here, I'll do yellow on that, is at the EMF of the battery, right? Because if we come in at 0 right here and we go through the battery, we have to rise by the EMF of the battery. Now we've gone through a resistor and we've dropped by some amount, I times R. So now we're at a lower potential. So this is a different potential here. So you can see that right here, the potential right here is not E, it's E minus the current times the internal resistance. So our load resistor doesn't see the full EMF of the battery, it sees less than that. We call this the terminal voltage. And you can see my voltmeter is hooked up to the terminals of the battery, and that's what the load resistor sees. So I can figure out the current. I want to know what the current is. The current, V equals IR, so the delta V across my load resistor, it's what I'm measuring with my voltmeter. That's going to be I through the resistor times the resistance there. So the current is whatever voltage I measure when this circuit is hooked up, divided by the load resistor. So now I know the current just by measuring this voltage. Now I need to figure out what that internal resistance is. So I know the EMF because I measured it up here, right? I measured the EMF here when there was nothing hooked up to my circuit. Now I want to figure out what that internal resistance is. So I know that my terminal voltage is going to equal the EMF minus the current times R internal. Because I come in at 0, I rise by the EMF of the battery, and then I drop by IR internal, and then I come out at the other end. And that's what I'm measuring with my voltmeter. I measured V terminal with my voltmeter. That's the same as V load. So if I plug that in here, I've got V terminal is the EMF, which we measured earlier, minus V terminal over R load, which we've measured both of those. We know what those are, times R internal. So now I can solve for R internal. It's the only unknown in this equation. I've measured everything else. This I should write here. This is measuring V terminal. While the load resistor is hooked up, I'm calling that V terminal. So we've measured this value when there was no load resistor there, when there was just an open circuit. Then we measured this value when there is a load resistor there and there's current flowing. Our load is the resistor that we're putting out here that's connected to our battery. And the only unknown is our internal. That's internal, INT.